Hey, it's Bill Trombley from Trombley Tool in East Troy, Wisconsin. Today's video is in regards to Fulton Metalworks beading dies that you'd use in a Polmax machine. Today, because it's warm out, we got the hangar door open, so you might hear some background noise. That's just the way it has to go today. So the die assemblies that he has comes with holders. This would be the lower holder, and this is the upper holder. Rectangular or square shanks, designed for Polmax machines, and I think he has all of the shank sizes. Easiest place to buy this would be Trick Tools. If you looked up Fulton Metalworks on Trick Tools, you can search by brand on their website. And Stan has a couple other dies as well on there. So high quality stuff. And then you have three different bead options, three different radius sizes. These are two different of the upper dies. The third one is in my trump machine. And then you have three different lower dies. I know it's maybe a little bit hard to see, but if we go like this, maybe it'll be a little bit easier to see. Yeah, there we go. So you can see the half round. So your first pass, you would have this die like that, and it's a through slot. So you would put in the full length of the bead, stop, lift up the upper die, take the lower tool out of the holder. This just sets in this holder. Flip it over. And when you flip it over, you'll see this half round pocket like that, and it'll coin the edge of the bead. And we're going to do a demonstration. I know how videos are sometimes where it's like, well, what does that all mean? So what we're working on today, a customer had asked, he's got a rush if I could put the beads in right away and send it back to him. He's out on the East Coast, and he needs to have a bulkhead like this with these beads put in it. And what this is for is a Fairchild PT-19. Would have been also used on the PT-23 series aircraft. And this mounts right behind the pilot seat. And you can see how the factory had put in the beads. They did a pretty nice job. What's common, a most common result that you would get if you used a bead roller is something like this. It's very warped and difficult to control, and that's because of the way the stretch occurs in the bead. The benefit of Stan's dies from Fulton Metalworks is the way the design of the way the tool is designed is it helps trap the material and only stretch it in the bead area, where this doesn't have that, and that's how come all the distortion is bad. Can I get into more technical explanation? Yeah, the easiest way to explain it is that they just work very well, and they work much better than a traditional bead roller. What we'll do is we'll demonstrate it in the machine so you guys can get a better idea. So let me go ahead and get reset up, and then you guys can see the process. So the noise in the background is our rotary phase converter, and then we need that to have it so we can run this machine. So this machine here is my trump machine. This is a CN900 with a duplicator table on it. The benefit of the duplicator table is that I can hold the material and I can accurately move the material parts back and forth. So I can put all the beads in straight. In the past, I've used machines that did not have a duplicator table, and you'd be using a fence to try to keep things straight, and that works, but it's much more of a challenge. I see now there are a number of people that are starting to build duplicator table kits to retrofit old machines. and I'd highly recommend it. This machine, I can move the table this way and in and out. I can move it in both the X and Y direction. And another nice thing with this machine is I can set mechanical stops. So this here is a stop block. And the carriage comes up and touches the stop block. And that way I can control my depths or the lengths of my beads in both directions. So finding machines that have the table on it, the duplicator tables, you can find them on Polmax, Trump machines, probably a fair amount of the old school reciprocating machines, makes jobs like this become a whole lot easier. I have my stroke length, or how high the tool moves up and down, set at 2 millimeters, which is approximately 80 thousandths of an inch. I could go with a more coarse stroke, but then you run the risk of seeing tooling marks. I can go down to 1 millimeter stroke length, which would be 39 thousandths of an inch. The challenge with that, though, is it's hard to move the material through it, and that's just because the up and down is so little that it's hard to advance the material. So the first, I'm gonna have to go up. The first pass is with the lower die set in the slot position. So we'll put that in. And then I'll bring the tool down and I'm going to make my first pass. Let's see here. Wish I could get you up. So let me reset up. Hold up one sec. So now that I have it reset up higher, the camera. You got to remember, guys, I'm still doing the camera work by myself. On the surface of the part, let's see here. Yeah, you can see it. I have lines drawn of my start and my stop and my center line that I want to follow. So I preset the carriage on the duplicator table so that it follows my marker line, and I preset my mechanical stops. And then what we'll do is we will make the pass. Always double check that you have the dies in the lower die in the correct orientation before you start, or otherwise it won't travel if I had that lower die turned in the wrong direction. And also that my mechanical stops are set, and then I have the carriage locked. I can lock the carriage, that way it doesn't try to put a bead in going this way when I want the bead to go in this way. We've all made that mistake. Pass number 2. Pass number 3. So this machine has an electric control that controls the shut height with a foot pedal. So now I bring the tool up out of the way, turn off the spindle. It's important to turn it off. Yeah, remember that thing's going. It doesn't care what I shove through it. And you don't want to have it that when you're making a die change, that all of a sudden you come up and you hit the tool. So it doesn't take much longer to just shut off the machine. And now what we're going to do is we're going to take the lower die from the slot position and we're going to turn it into the captured position. This will be underneath like that. And what this will do is coin the end of the bead. So that just sits, nests in this holder, and we'll see. Can you see that down there or not? Yeah. So it just, there's the die, and that just sits in there like this, and it drops in. And what that will do is it'll coin the end of the bead. It'll coin it like how these are. Let's see here, like that. And what coining does is it makes it so it has a nice finished rounded edge on the bead. So by taking the lower die and indexing it so it's captured like that, we're going to coin the first edge. So it's coming down very close to the material, and I'm going to just bring the die down until it reaches its full depth and right back up. And just like that, the end of the bead is now coined. It has the nice rounded end of the bead. That's what coining would mean. So now what I do, take out the lower die, that's like that, and I put it in this way. I index the lower die 180 degrees. I bring the material down to the other end, and now I'm going to coin the other end of the bead. Take the lower die out, turn it back to the through slot. Now re-index down to my new marks. Relock the carriage, and then I would bead again. So the way the part works is the center bead is the longest, and then going out from there, they progressively get shorter in length, but they're the same length on both sides of the center line. So I don't have to reset my stops on my carriage, because I started in the center, I go to the left and to the right, or put in the center bead, go to the, change the stops because they're a little bit shorter, pound in the bead on the right hand side, pound the bead on the left hand side of center, reset my stops, go shorter again to each length that I have marked. So it's a very effective tool, and it's great for projects like this. Is the panel flat? It's pretty darn flat. And you'll see that it has a slight bow to it. How do we get the bow out? Once the panel is made completely, I'll pull it back out, and it's soft material. It's 3003 H14 material by 40 thousandths thick. And I'll be able to just take the material and push it flat, and it'll work good. So, hope that all makes sense. And I'm going to go ahead and I'll finish up the beads. Be right back. So this piece now is the finished part. Pretty damn straight. Not perfectly straight, but nothing compared to the amount of grief that you could have by going through a bead roller. It's a slight amount of adjustment instead of a lot of adjustment. No pre-stretch like you would with a bead roller to try to get them to be straight. And that's because of the way the dies are designed. So we have a guy coming in for a landing. Just hold on one sec. Guy would be able to log 3 of those landings in one shot. But you can see here. So one thing you notice is, versus the sample, is I didn't trim the outside. And I also, the area from here to the bead to the edge is longer than what the sample was. That way it's not interfering with the clamps on the machine. Now that all the beads are in, this can now get finished, trimmed, and be done. So, thought some of you guys might like this kind of a video. Remember what I said in the past. Buy tools that were designed by metal shapers for metal shapers. It helps out those guys tremendously, and there's some very good products out there that have guys that have put a lot of thought into it to try to make it so that these tools work. And it's all made here in the United States, and that's just awesome. So, hope you guys liked the video. Like, subscribe, tell all your friends, and more to come. Thanks. Have a good day. Bye.